Ladies and gentlemen, a very warm welcome to each and every one of you. I am Prasadini Wickramasinghe, a renewable energy engineer by profession and the coordinator for the Greenstat Centre of Excellence in Hydrogen. Allow me to briefly give you an introduction about the Centre of Excellence in Hydrogen. The Centre of Excellence in Hydrogen is dedicated to empowering industry professionals and accelerating the development of thriving green hydrogen economy. We intend to achieve this through industry-leading education, training, and knowledge sharing initiatives. From complete training programs covering production, storage, transportation, and utilization of green hydrogen to workshops and webinars such as this, designed to bridge the knowledge gap. Also, it is worth mentioning that the Centre of Excellence in Hydrogen facilitates collaboration between academic institutions, research bodies, and industry leaders to develop a future-proof green hydrogen agenda. And we are planning to offer certification programs to equip professionals with the necessary skills and qualifications to succeed in this expanding sector. Now, before we delve into the heart of today's webinar, I'd like to draw your attention to our esteemed partner for this event, Dräger, the global leader in medical and safety technology, stands at the forefront of innovation and excellence. To shed more light on Dräger's invaluable collaboration to safety and technology, we are privileged to have with us Oliver Bornholdt, the Global Business Development Manager at Dräger. Oliver brings over 25 years of diverse industry experience to the table. Not only is he a certified Six Sigma Green Belt, but he is also a dedicated advocate for industry safety with a keen focus on digital transformation and new technologies such as hydrogen and ammonia safety. Also, I want to take a moment for honorable mentions starting from USA SADC for their invaluable support of our program in Sri Lanka and extend our sincere gratitude to the government of Sri Lanka for their support of Greenstat. Also, the National Science Federation, NSF, helped us promote webinars such as this through their science and technology management information system within the scientific community. Before we proceed, I'd like to make a special announcement. This webinar marks the beginning of our safety seminar series, and your engagement is instrumental in making this webinar a success. Also, I am happy to announce that Dräger has generously provided a free digital white paper on hydrogen safety for all participants of today's webinar. Without further ado, let's kickstart this session. Over to you, Oliver.
So I hope my camera is working, so that's fine. I have to, from time to time, I have to look a little bit to the right because here's my other monitor. Thanks, Prasadini, for the nice intro. Also, warm welcome from my side here from northern Germany. It's a bit raining when I look here outside, but spring is coming, so that means trees getting green. And I welcome you all. Before we start, so that everyone knows, we will record the webinar. And there will be at the end some Q&A time left, so you could put in here in the section so that nothing will get lost. And at the end, you will get a follow-up email as well with some feedback survey, a short feedback survey. It would be very nice and warm and welcomed if you could take this minute for us. Having said this, I would like to go on and just start. What is to expected? It is a quite broad intro into hydrogen safety. So we as Dräger currently involved in roughly 1,100 projects globally. So this is the latest status. And it's really, I think, from the whole eco chain. So it really starts at the beginning, at the production, and goes down, let's say, to the off-taker market. Having said this, and here you see, I have to, from time to time, look to the right. I would like to introduce ourselves here a bit as well. So Dräger in profile, we are roughly 3.5 billion euro from last year, a little bit over 16,000 employees. So we have two big branches. One is medical. You may know us from medical as well, doing respiratory care and a lot in hospitals mainly. So that means roughly 10,000, a little bit less, are in the medical, and a little bit over 6,000 serving, let's say, the safety infrastructure. So we are more or less everywhere in the world, either with our headquarters, which is here close to the Baltic Sea in northern Germany, and we have a lot of production sites, logistics centers around the world, and for sure the sales and service organizations also here in Mumbai are there for you. Also here, let's say, when we talk about Sri Lanka, where currently my son is. He's doing 2 weeks holiday, so we're chatting every day, and he enjoys the country very much. Having said this, I would love to know a little bit about you. So there will be a kind of poll question coming around, because I would love to know a little bit who is online, and yeah, before we start, to know a bit about where you are currently in terms of your knowledge level. So please take 1 or 2 minutes. I think, and I hope, I look to the right here, that the polls are going through. I'm not sure if I can see them, the results a bit, or someone from my colleagues can give me a ping when you're ready. And then we can share the results maybe as well, if possible. There's some heads up as well during you answering the questions. This will be kind of series of webinars, depending also on your feedback later. So that means we're starting today with a basic overview, and later we will go deeper and deeper, either in applications, in regulatory and compliance aspects, into really risk management measures that helps you either on site, in your processes, with your company, bring you on a, let's say, on the level really to run a safe hydrogen infrastructure. Maybe some of my colleagues can give me a ping how far we are with the poll questions. Can we share them already? How far we are? Okay, we take a minute more.
We are done with. So the one that we can actually talk about that's visible is in terms of how do they rate their expertise, is 52% have mentioned medium and 42% have shared a bit low. And 6% have mentioned that they are experts in this particular section.
Yeah, thanks for that. I would say that gives me a bit of a frame where you are currently, and then I think we can close the poll, right? So, and then we can go on with, let's say, with the info.
Yes, we can move on.
Okay, great. Thanks. So let's mention where, as I said, where we are currently and where we are active and how we see the whole, let's say, infrastructure of this whole ecosystem. It starts really here in the beginning, so that means really in the production of hydrogen and the storage. We see currently 400 and a bit more projects globally, from lab and pilot projects to large-scale projects as well. So when we talk about gigawatt scale, like in Saudi with the NEOM projects, you may have heard about that. So there are a couple of very large projects as well. And then it really goes down the line. And it really depends on where you are. We see in Europe, for example, a lot push here in the mobility sector, especially when we talk about heavy duty vehicles, and in a lot of countries in Europe, in Germany, in the US as well, speaking mainly for California, in Japan and China, they are already heading here, building up, let's say, the refueling infrastructure. As well, all these trucks and all these heavy vehicles need to be maintained somewhere. So that means also the repair workshops needs to be equipped with let's say, certain standards, and with standards that may come later in other webinars. So you definitely have to know where, let's say, where to build up your knowledge. And we've been introduced into some steel projects as well. It means green steel. There's a lot demand on the world market, here we are as well. So as I said, there's a lot to do, a lot to learn, also from our side. So that means your feedback is very much welcome. And then going on here in the presentation. So that means production, storage, and transport. Nowadays, let's say hydrogen is mainly produced by steam methane reforming, by gas is the majority, and still not so much, but this needs to be changed by electricity. That means by electrolysis. The storage, there are big projects stored on long term when we go into mass production, into older salt caverns, also depleted gas fields, also on the horizon. And we've seen here some projects in the North Sea, and for sure liquefaction, but you may know it. This is also quite energy intensive, so that it's really a question how far this will go. And then for sure the hydrogen needs to come to the end user. The whole transport, either over short distances or over long distances via pipelines, is definitely a thing where we look in and where we got pulled in some projects currently as well. Yeah, talking about transport, it's even more complex. With my mouse, we talk about hydrogen maybe for trains, so large vehicles here as well. Aviation, a lot of airports currently preparing themselves for the future. So that means this could be an addition in the whole decarbonization strategy as well. Yeah, industry, one of the largest off-takers, steel, for example, or other carbon-intensive industries as well. And last but not least, heating, but this may come a little bit later. We've seen some pilot projects here in Europe and in the UK, but I don't think that currently the hydrogen is too worthy that it's really directly burned into households. So that means the hard to decarbonize industries, what we see here, or the transport, will be the first ones who will get, let's say, a green hydrogen. Some of you may know it already. Hydrogen has certain colors when we talk about that. The majority currently is talking about green hydrogen. So that means this is really zero carbon from renewable energies over electrolyzers and then producing green hydrogen. But there are other ones, we could say carbon neutral ones, like, for example, blue hydrogen. Blue hydrogen is produced by steam. This is SMR, steam methane reforming. And then the carbon dioxide is captured, either used, CCU, or stored, CCS, as well. So that means this is also part of the game currently. And we have some other technologies as well. When we talk about methane pyrolysis, then it's called Turkey's hydrogen. And then are for sure gray and brown hydrogen, where how they are currently produced via gasification from coal or steam methane reforming when the carbon dioxide is not used at all. But okay, first of all, some of you may know a little bit hydrogen, some of you don't. Originally, I'm a physicist, and I say hydrogen is 99 or let's say 98% of the universe consists of hydrogen still. But this gas is, on the one perspective, quite easy. It's only one proton, one electron, but it behaves in some instances like a diva. And I will show you why. And why is this so important to keep these 10 safety challenges in mind? Because this is quite important for further planning. The first safety challenge that we see is knowledge and education. So what we see here are some lessons learned from previous incidents. They are collected from hydrogen, the Center of Hydrogen Safety. So we are a member of this non-profit organization as well. And what you can see here is that the majority of incidents that have been analyzed are, let's say, leaking connections or leaks in general. So this is what you can see is here the majority of that. Later, it comes a little bit to, let's say, material causes as well. But the majority is leaking connections and valve malfunctions. So that you could say, okay, yeah, but what does that mean? It's good to know why knowledge and education. When you look a little bit deeper, that the majority of incidents is, let's say, from the operational and even the procedural planning stage. Who is involved here? People. So that means in A, B, and C, and D are, let's say, people involved. So that means knowledge, education is really key. There's a reason why we're here. Safety challenge 2, permeation. Hydrogen, as I said, is the smallest molecule in the universe. It can permeate and brittle under special conditions materials, even stainless steel. But you know, since centuries, this is right known. It's just a matter of knowledge, right choice, and handling and maintenance of them. Here you see the founders of Dräger. It's really 130 years ago when we started producing first gas pressure reduction valves. Some side note, the first reduction valve that Dräger involved was for a beer dispenser. So we started from there. It's just a funny side note. But from there we started, and then this whole, let's say, endeavor within Dräger and medical and safety started. Safety challenge 3, leaks. Due to this small molecule size and low viscosity, it needs really the right engineering and the right construction. So that means maintenance of, let's say, the facilities and a regular plant inspection is needed. It's in most cases regulated as well, and it needs fixed gas and leak detection as a layer of safety. And I will come later to that. Number 4, carbon dioxide alarms. Who could say, hey, why is this so important? In some applications, talking, for example, in the steel industry, you have both. So you have maybe carbon monoxide and you have hydrogen as well in this environment. And you have to know, knowledge, that these CO sensors are and can be cross-sensitive to hydrogen. So that means you may have an CO alarm, or let's say your alarm device gets a ping, but you do not know, is it now CO or is it hydrogen? So that means, once more knowledge, you have to know is the sensor compensated for hydrogen? Side note, Dräger has these sensors. Otherwise, yeah, you have false CO alarms that, that can happen. Number 5, gas pockets. Ammonia, methane, hydrogen are less dense than air and form gas pockets. And this is very important to know, especially during a risk assessment, especially during an assessment locally, where, if you have a possible leak, can hydrogen, methane and ammonia as well, let's say, can form gas pockets. Why is this so important? We talk about explosive zones. If it's outside, that's maybe fine. Maybe sometimes you have some of mixed infrastructure, or it's even indoors. Then you definitely have to know where it could be possibly happening. And especially in environments that are grown already. I've mentioned train maintenance halls. They are maybe decades old, and we are currently in discussion with some of these maintenance engineering companies. There you have to be very, very careful, because at the top there can be formed gas pockets, and you may have old, let's say, electrical interfaces there and lines and so on. And this needs to be analyzed very carefully. Otherwise, you can get in deep trouble. Number 6, no odor. We know it maybe from other gases. Our nose is very sensitive to them. For hydrogen, it's colorless, it's odorless, and you cannot detect with your nose, and you cannot even see. So that means we really have to trust the technology here. Number 7, and it has an invisible flame. Maybe you can see this here, but here is a hydrogen flame in the middle, and you cannot see it. When it's daylight, it's more or less invisible. I've seen that. If it's dark, you can, maybe if you would know where, you could see it. And the other problem is you will not feel it. So that means there's hardly no IR, which you maybe could feel on your skin. It's no, you can see it barely emits infrared, but substantial UV radiation. Neighboring objects are less likely to catch fire, so it means you may have a fire here, but you cannot see it. But flame detection is necessary. Number 8 is invisible for IR, so that means a purely IR sensor cannot detect the sensor because of these missing CH bonds. But there are catalytic sensors that should be used, and they can detect it very, very sufficient and very, very sensitive as well. But they need to be calibrated. Number 9, X protection. The biggest threat from hydrogen is that it can lead to an explosion. I will come in a minute to that, what that really means. So that means depending how likely explosive atmosphere can occur, X areas have to be classified. And the classification needs to get stricter. So last but not least, number 10, ignition. Leaks of pressurized hydrogen can also self-ignite without an ignition source. You could say, okay, why can that happen? There are 2 things that you don't know about hydrogen. The first thing is maybe known. The self-ignition temperature is, correct me if I'm wrong, 580 degrees roughly. If you have surroundings where you have a higher ambient temperature already, it could be in the steel, in the petrochemical, or somewhere else, it could happen that hydrogen can self-ignite. And there comes another thing into play. As I said, hydrogen is a kind of diva. Hydrogen is the only gas in the universe that has a reverse Joule-Thomson effect. So a Joule-Thomson effect by having a kind of hairspray, and you spray it on your hand. What happens to your hand? It gets cold. If you have high pressured hydrogen and release it, vice versa, it gets hot. So that means if you have maybe already a higher ambient temperature and you have then this reverse for a high pressured leak, in the mobility part, you have either 300, 500, or even 700 bar. 1,000 bar is in discussion. You can see what can happen with a high pressured leak. So that means, and on top of that, next slide here, the ignition energy here on the right side is 15 times lower compared to methane. So that means it really needs a small spark. If you have, this maybe from your shirts or from your pullovers, when you sometimes have these kind of sparks. This is 100 times higher than you compared to what the ignition energy of hydrogen is. So what you see here, it's very sensitive to, let's say, to ignition sources. The molecule size, what you can see as well, is the smallest in the universe, also compared to oxygen, compared to carbon dioxide or even methane here. It's compared to methane, it's 4 times smaller. And then the density compared to air, 14 times lower than air. So that means at the outside, it gets quite quickly up, but has then other disadvantages when it goes into the atmosphere. Hydrogen, you may don't know it, but it's a secondary greenhouse gas, so there's also discussion around that. And what I would definitely love to mention here, the burning velocity is 7 times higher than gasoline or methane. That means also the explosion energy and the destructive energy of a hydrogen explosion or deflagration is a lot higher than for other gases like methane. But you could ask yourself, okay, but how to start where? And I said, first things first, be aware of the risk. We've mentioned already, hydrogen is odorless, colorless, tasteless, is a kind of diva in the universe, and our human senses will not help you to detect the leak. So what does that mean? 3 things. First of all, line of sight. How to see it. There are technologies, and we may come later in other webinars to look a little bit deeper into that. Open path gas detector, flame detectors, very, very important, or even gas cameras. Then the point detector. So that means really smelling. Flammable catalytic gas detectors are here the right choice to choose from. And last but not least, which is very important, to hear a leak before it gets to a certain level. That means above these 4% volume concentration. So the earlier you know about the leak, the earlier you really can look for, let's say, alarm mitigation measures. So that means an ultrasonic gas leak detection is here very, very important, especially for hydrogen. Yeah, having said this, we all have a duty, and that means we all are in this business, and we have to know at least about the basics. I can only scratch a little bit the surface here, but there are in every country basic laws. There are laws about legislation concerning health and safety at work, and I'm sure we have here some health and safety engineers as well in this round, so you know it. There are country by country accident prevention regulations. There are maybe collective agreements and government regulations about workplace safety. And then for sure at the end, ISO norms, NFPA norms, EC norms. So there are a lot of technical rules as well, and you definitely have to know them. This is not an excuse if it comes to an accident that you say, oh, I didn't know that. You are liable at the end as an operator. But this is maybe a separate webinar when we look deeper into what needs to be known in terms of all these norms and standards. But at least I would love to give you an overview here what you have to know. At the end, either on your side, either with help of a company like we or maybe someone else, normally you have to ask yourself a couple of things, and maybe a safety consulting workshops. These are questions. How can you define yourself safety goals? And do you know all the hazards? So this is quite important. And for that, you can go through a risk management process. So that means you can look through, when we look to a plant life cycle, from concept phase to, where's my mouse? Here's it. Concept phase, the scope and risk phase, the requirements, nailing down, over planning and scheduling, and so on and so on. And over all these, let's say, phases, you have to look at what needs to be done when. And this is a big question. So that means you have to define your safety goals. Here you have to know, okay, what kind of regulations are really needed to know. And based on that, for sure, you can set up your safety concept, and so on and so on. So it goes on here. And as I said, you need to have a hazard identification, including a risk assessment and later a risk prevention planning. At the end, it comes out that different methodologies can be used. Risk matrix, low pass studies, fire and gas mapping and modeling, and we can go into this as well a little bit deeper, not today, maybe later. Training of your staff, as I said, a safety challenge 1, training and education. At the end, you have to document all this. So this is definitely, but maybe you are in already for other gases or other operations, then it's maybe fine for you and boring. But for some of you, this is maybe new. And especially for hydrogen, I can tell you from the experience over all the projects that we've done in the last years, sometimes the devil is in the detail, I would say. So 5 important questions you have to ask yourself. What are the individual substances' properties? As I said, hydrogen, you need to know how this will behave and what is so special with that. What amount of hydrogen do I accept, either locally stored, and so on and so on. What damage scenarios can occur? So that means it's really an outcome out of risk analysis, and this gives you a clear view on what needs to be done, architectural, process-wise, and so on. What type of activities in general are performed, like we see here? It's a kind of bunkering scene, but it can be something else as well. That needs to be listed down, and what safety measures have already been taken. I guess, yeah, you have already something, but this needs to be part of the discussion. And at the end, you have to see, okay, where are the gaps? Having said this, risk assessment has to do with risk control. So first of all, you could say substitute. We need the hydrogen. We want to work with hydrogen, so substitution will not work. Engineering controls, yeah, for sure. This is definitely important. I will come to that. What does that mean? Administrative controls is also like training, like process descriptions and training on these kind of things and documentation. And at the end, when nothing helps, I would say, or it is another safety layer, the personal protective equipment can be also part of that whole picture. So when we look to such a process, may you know this, may you've seen this, may you've done this already in your organization. It's okay, what do we want to do? What is new for us while we introduce hydrogen here? And then you start over, let's say, the risk assessment here, risk identification, the analysis, and the evaluation, and at the end, the treatment. So that means taking measures. And you have to communicate them, and at the end, you have to monitor and review this on a daily, weekly, monthly basis. And the regulatory bodies will look into that. I'm sure we have here in this audience maybe people from regulatory bodies as well. So that this is part normally of an audit as well. Yeah, safety consulting. What is that? Normally you have a kind of environment where you work with hydrogen. Can be a complex complex environment with a lot of hazards, and you may identify them. That could be something where you work on. Maybe a lot of more persons are involved here. Maybe you have a storage facility and someone who, then you go through it. You just check it. You do a hazard and risk identification on site. It could be an addition, so that you want to work with hydrogen from now on. Maybe it's a facility that you own already. It could be a maintenance facility. It could be something else. But you have to start at this risk consulting and risk identification measures. Then you do a risk assessment. So you really look into the details. See, okay, do I have the right equipment that can detect hydrogen in this, let's say, in these procedures? And you really look into, let's say, these tables. I will come to that in a minute. But last but not least, what about escape when something happens? Is everyone trained? Do everyone know muster points? When it comes here to the fire services, do they know what they expect? So what about the data? Do we know the concentrations? And so on and so on. So this is part of such a safety consulting and risk assessment. We are concentrating on escape as well. Having, let's say, looking into that, what kind of methods needs to be known? It's just an abstract. Classical hazard studies. It could be a fault tree analysis. It could be an event tree analysis. LOPA, I've mentioned this. Maybe some of you know, but we can have a separate session on this as well. And for sure, an FMEA, which is quite known in the industry as well. So this is part of the ISO IEC 31010. And it's definitely a must that you have to go through. Yeah, risk assessment, it's normally done in several ways. So where's my mouse? Here's my mouse. So one thing is that you define the likelihood of occurrence. So it can be most likely or maybe inconceivable. And then you look really with your specialist about the severity of damage. And then each and every working procedure will get a kind of, let's say, of number. If you go through that at the end, you will get your measures. And then you have to do something. So that means either eliminate the hazard, substitute the hazard, which will not happen because we cannot eliminate the hydrogen because we want to, and we cannot substitute it. So that means it starts here with engineering controls. You have to isolate people from the hazard. Administrative control, change the way people work, but it starts with isolation. Fixed gas detection is one thing. So that means really early leak detection. You have to have explosion-proof electrical equipment as well, clothing due to the high ignition energy, a planned fire protection processes in place as well, and for sure ventilation when it's inside, even outside. I've seen electrolyzer facilities, they got a roof. It's kind of Venturi roof, so that you have a natural ventilation possible. But here I can tell you also with these Venturi roofs, you could have weather conditions where they will not work. So, and I figured this out here. We had a project here in Germany. I've seen an electrolyzer with a Venturi roof, and clearly talking to, let's say, weather experts, it's okay. We could have fogs and so-called reverse weather conditions where these kind of Venturi roofs will not do the job. Yeah, change the way people work. Remember, knowledge, education. You have to work on a safety matrix. If then, emergency stop, emergency and hazard prevention management procedures as well. Permitted activities. So it means I don't know if you have a permit process in work, especially for maintenance activities. And then, blowing off hydrogen and so on. So these are obvious things. And at the end, last but not least, protect your people from the hazards. It could be mobile gas detection that you wear. Could be a thermal imaging camera, which is sensitive to hydrogen as well. I think it's flame cameras as well, ESD, safety shoes, and so on and so on. So you know it. I think this is clear, but at least it gives you where to start and where to follow this hierarchy. Yeah, explosion protection. There are, so let's say, three sectors. The first is prevent an explosion, explosive atmosphere. So this is the primary explosion protection layer. So that means for sure gas-tight constructions. Yeah, this is a given. This is a no-brainer. Remove gases quickly, so that you need a ventilation system. But here as well, ventilation, cross X protection. It's also quite important to do. And then, last but not least, detect gases quickly. That means as early as possible, at very low concentrations, remembering what I said about ultrasonic gas leak detection, so that it's even, especially outside where it dilutes quite quickly, the gas has to come to the sensor when we talk about electrochemical sensors. But ultrasonic is definitely a thing where we very early can detect already a leak, also very small leaks. Secondary is prevent ignition sources. Yeah, we've mentioned this a couple of times. X-certified equipment, mechanic instead of electrical equipment. Quite important when we talk about maintenance facilities where we have maybe electrical ventilation on top of the roofs. I've seen this as well. So this needs to be thought over. And grounding and conductive floors. And then last but not least, tertiary. It referred to constructive explosion protection. So that means you have to have special fireproof and retardant materials and walls and also ceilings. I've seen explosions already on test facilities, and I can tell you this is eye-opening when you see what kind of destructive energy hydrogen really has when it comes to an explosion. And the velocity is a lot higher than for other gases. Yeah, use pressure relief valves and so on, and mark ways for evacuation. This is a no-brainer. Gas detection is seen as a primary explosion protection measure, and is to prevent explosive atmosphere. So before it really comes to the extreme. Implementation documentation, as I said, holistic safety concept. This is audited as well. So to be compliant and to take your duty, you have to have a holistic safety concept, including all the things that I've mentioned here, including at the end as well an emergency and crisis management can happen. It depends on the volume of hydrogen that either you're producing, storing, or transporting. This could be part of this as well. Round this up. Is hydrogen safe? Hydrogen has some pros as well, because hydrogen is not normally explosive itself. As I said, it can be normally not self-igniting. When it comes to higher temperatures, it is, but normally under ambient temperatures, not. It is not oxidizing. It is not toxic. It is not carcinogenic. It's not acid and not radioactive. So these are some good ones. But at the other side, it's explosive at certain conditions, 4 volume percent upwards. It's extremely flammable, and it's challenging for safety and requires. Remembering the 10 points, education training, it starts there. You have to knowledge about the equipment and the materials, protection measures. It is colorless, odorless, so our senses will not work. It is almost invisible when burning and suffocating when displacing oxygen as well. So that means, conclusion, hydrogen has some safety advantages. I think this is, the mouse here. This is clear. It's very high flammable, and it bears safety challenges. So does it keep you off from dealing with hydrogen? Not. It's a matter of, I have to know it. I have to look deeper into that. I have to know the regulations and the compliance, and I have to know what kind of protective measures are needed. Also from a regulatory point of view, or maybe your internal rules give you something else as well on top of that. Now, having said this, I would love to close my presentation. So either you can ask me, you can connect with me via LinkedIn, also with my colleagues here. I will forward this as well if something comes around. And now I'm open for questions. If you have some, if you want to ask them later, no worries. You can send us an email as well. And for sure, there will be a lot more webinars in the future around safety. And you can do also some wishes what you would love to see, because we will send out a kind of feedback survey to you as well later, and then you can hopefully give us some worthfully insight as well, and also hopefully some nice, I hope it was worth some nice feedback as well. Thank you. So far so good. So I'm over with my presentation, open for my colleagues here, waiting for my colleagues here in the background. May we have some questions here as well, and I will stop sharing my screen.
Sure. Oliver, there are a few questions in the question chat box. Do you want us to read it out?
Mm-hmm.
Yeah, so the first question is, while the detection of hydrogen is not advisable to use IR cameras, but we would like to know even thermal-based cameras would also not be supportive enough to detect these leaks, right?
So let me check, can I see the question somewhere or not? I cannot see it, right?
Yes, you can, in the questions chat box, if you can just have a look.
Question chat box. Let me just check it. Bear with us a minute. Where's the chat box? The chat. Only our internal chat that I see.
Now.
Your screen, and then we can have a look calmly on that,
Yeah.
if it is possible.
Sure.
Easier for me to remember the question and then look deeper into that. Can you share this?
Yeah, just give me a second. I'll just do that.
Okay.
I think there's some issue with sharing the screen. We can, once I have it, I'll just project the screen. Just give me a second. I think the green team from Greenstat can take over if they're there.
Yeah. Thank you, Oliver. Am I audible?
Yeah, I'm here.
Okay. First of all, I would like to thank USAID and Government of Sri Lanka for allowing us and supporting us in this particular webinar. I would like to thank the Dräger team in Germany and India for an excellent support and also preparation for this one. I thank all the attendees to this program. I've been told that many of the attendees could not have a patch which is required for this particular platform. I would apologize to them for that inconvenience. We'll be sending the recording immediately today. We'll be getting from Dräger. And particularly Oliver, an excellent presentation, if I have to mention. I have been in this hydrogen industry for only 2.5 years, but the first time I could get very, very clear inputs on how and why and where we can. In fact, the 10 points what have been mentioned by you, the risk matrix and the management process which has to be done, the explosion protection, the primary, secondary, and tertiary, the way you have mentioned, the interpretation and detection of that, and the pros and cons, finally, the way you have mentioned it, has brought us really, and the triangular matrix, what you have shown clearly explaining the basic laws, legislation, and which are legally binding, the standards, and finally you have hit the nail on its head when you tell you are liable and responsible for what is happening on the ground.
Exactly.
I think it gives a lot of input to each and every. It's not like any other industry. We all have been in the energy power industry with solar, wind, and etc. But I think this is an industry where it has got all the pros what you have shown, but we have to respect the cons, and we have to really make things happen. And the seriousness of this industry has been very clearly articulated by you in this. And we would like to have a continued inputs, as you said, that separate presentations are required for each of the blocks, what you have mentioned. I'll thank Prasadini, I'll thank Sterle, and the team who have made these things happen. And with this, even being a holiday in India and Sri Lanka, I could see around 50 participants coming into the picture, and a lot more will be shared the presentation and the recording. Thank you once again, Oliver and your team. Thank you very much.
More than welcome.